Hi guys, now let's move into the data architecture. In the previous section, we have seen that in the application architecture, what are the primary things we are going to cover. But just please note that this is not that I am saying that in the application architecture only you are going to cover this. This may be uh, implemented in the broader section, but for now to remember or while applying the NFRs, I am just classifying this so that you can remember. Now it can be across your whole architecture space. It is not that um, it is just in this particular space, but in the overall architecture space, both in the data, in the application, in the technology, in the business, everywhere this will be applied. But I am classifying so that you can remember this. Okay, now in the data architecture, what are the key things you need to remember? That is what we are going to discuss, and it is not only related to data but across. You have to remember this. Now transaction and consistency is one of the key things you will be remembering the moment you are entering the data space, right? Now many systems are transactional or have transaction element. At least if you may say that it is not a transactional, but you can have some transactional elements in those system. Transaction are used to help and ensure that data is kept in a consistent state. So here in the diagram you can see how your data you are keeping in a consistency check, and you are keeping everything in space. Now how the transaction and the data consistency model will be, it is depending upon you, but the transaction and the data consistency model that you choose can have a far reaching effect on the system and is generally an architecturally significant concern. So you need to give a special care on the non-architectural input or the NFR part of it. Okay, now what are the actions you generally take is you consider how to handle the transaction and consistency in the system early in the project life cycle, and there any transactional element that needs to be taken care in the system. Now where are these transactional boundaries coming? Do this data traverse through many other systems? Do you need to share the data? Do you need an obligation in sharing the data? What happens when the transaction fails? Are you going to roll back the full data, or is it an half commit into the database and then you roll back? Now, are the ACID semantics required for all the transactions? That is also you need to remember. ACID, when I say ACID, it is about the atomicity, consistency, isolation, and durability. I mean, the four key properties of the database. Okay, so those things you need to remember here. Is the system part of an a consistent? Is it eventually consistent? And these sort of things you need to remember when you are going into the data architecture, so you can start documenting the NFRs for the data, a part of it. Now then comes the concurrency part of it. Now most system involves activity or flows that occur simultaneously. You are going and writing into the database simultaneously. You are not really means going one by one. Means it is not a serial but a parallel execution I am talking about. Okay, now when I am saying so, such kind of system that handled user interactions at the same time, do you need a parallel batch to be run? If the batch has to be run, what are the timings that batch needs to be run? When the batch is getting committed in the database, do you have a timing constraint? Now say for example in a renewal in an insurance system, or when you are optimizing your database in March 31st, say for example in closing for the banking system. Now are you going to write millions of records in one shot? How much time this batch is taking? Whether you have a window of 2 to 3 hours or 7 hours, can you bring the system down and update the system? Or you can't do that. Those sort of things has to be taken care while you are talking about the concurrency part of it. Now what is the data access and data leveling? That is the third part I am just talking about here. Now many system nowadays incorporate capabilities that are powered by AI. Now data is the key requirement for these AI capabilities, isn't it? Now, to you need to label the data to remember that what sort of things you are teaching your AI programming, or is there a supervised learning happening in your system? Is there self-learning bots are implemented in your system? So when you are designing this kind of system, especially when there is an AI involved, you need to talk to the data scientist on the project to determine the data requirements and the sources to ascertain how and when the requirements and the sources are getting updated. So that is another NFR where labeling the data is very much required, and to be sure to work out how the data is to be labeled and how the labeling can continue as necessary on the ongoing basis. Okay, so this is another key thing you need to remember while you are documenting the NFR, considering the database as a whole, from the enterprise level or from one project level. Next is about the backup and recovery. Are you backing up your data? What happens if the system gets crashes? How you are going to recover the data? What is the RTO and RPO of those systems? What is the last backup you are, is it a full backup you are doing? Is it an incremental backup you are doing? Are you, what is the timing of the backup getting stored? Are you, have you documented that? What is the minimum backup time? So those sort of things needs to be taken care in the data architecture while you are talking about the databases. And then comes the housekeeping. You are generating huge amount of log data inside the database while you are doing transactions, non-transactions data, and your logs keeps on growing. Are you going to delete this log at certain point, or you are not going to delete, you are keeping that as it is? If it is like that, then what happens to the system? The systems keeps on growing, you have to scale it. So those sort of things. So you have 500 GB of space. Now you have grown it to 5 terabytes, and from now to next 5 years, how much you will grow? Are you going to scale the system, or you are going to delete certain amount of data, at least the log data out of the system? Those sort of things comes into the housekeeping section. So that is what you need to remember from the NFR viewpoint of the data architecture. Now let's move to the next section and talk about what we can see in the network computing or the hardware view. Now there are regulatory requirements which also are very key. Now when I say regulatory requirement, what is a regulatory requirement? The regulatory requirement means the system needs to comply with the different kinds of law and regulation. Now when I say that, why I'm coming into the hardware view or the networking view? Now I am staying in Asia and someone is staying in US. Now you are dealing with a bank. Now US bank does not want the US data to traverse all the way to the country in, like Asia, and they want to keep it in the local network and it should not traverse. Now there is a breach. The Europe don't want their data to be traversed to USA, or they don't want the data to be traversed to the UK, to Asia. So in that case, how will you handle those systems? How will you handle the data? The regulatory requirements are very important. Those laws and regulations are very based on the domain and the jurisdiction where the system operates. So you have to consider them early in the software project lifecycle. You cannot ignore those things, isn't it? Now, why you can't ignore today? You know that the GDPR is also sitting on top of that. Now if you are following an insurance like HIPAA, Health Insurance Portability and Accountability Act, you can't take the data to, I mean, my health data to another country, right? I don't want that to happen. So those regulations are applying. So you also need to think, how can the system meet this regulation? Now this will be not a functional requirement, these are the NFRs you have to take care through. So be sure to consider those kind of factors such as encryption, then encryption in transit, auditing, traceability, those sort of things. So you must consult with your architect for the regulatory requirements, as well as you have to bring the regulatory SMEs into consideration, and then you start doing the traceability of those, and then you start documenting those, right? Next come the accessibility. What is this accessibility? Again, the data, we have spoken in the data architecture section what accessibility means. So you are accessing the data. Similarly, it is just a practice of enabling the software system to be used by everyone. Now, everyone means you have a defined boundary where you are saying your everyone means these people. Now, it is a key requirement for any software to make sure that you are meeting the legal requirements of those accessibility. So when I am saying the legal requirement to access those data, say my company wants my their software to be accessed by me and not anybody of my friend, right? So that is accessibility requirements. So meeting accessibility requirements forms a part of the key of the system software architecture. When you design the system, define the accessibility requirements and consider that how the system can be made accessible to certain people or certain amount of key users with whom you want to share the data. So work closely with the designers of the project to establish what patterns and approaches you want to use for the accessibility. And when you later make an architecture decision, consider what effect it has on the existing accessibility of the system, right? These concerns are likely to be relevant for functional architecture and design, but can also affect other parts of the architecture. So not to forget that, okay? And then comes the cost factor. Now, what is this cost factor? Now, you as a I mean, you are doing a disaster recovery. I mean, the next section of it. Now, when you are doing a disaster recovery, you are keeping a server in the US, say for example, and then when I say US, I am talking about say California at the moment. Okay. Now, one of your server is located in California, and there is certain problem happened in that California server, and the whole data center goes down due to certain earthquake or something like that, say for example, just for a consideration purpose. Okay. Now, when this goes down, do you have a provision in any other country or any other place within the US or outside the US where the key data can be recovered from? So you want to keep another server in the UK to recover the data if there is any problem. So those sort of things happens, and a cost factor becomes the key factor behind the success and failure of the system. So the architecture of the system can significantly impact this cost. So if you are keeping another disaster recovery server in another country, you have to bear some cost. So you need to remember that it will definitely directly impact the cost, and if you don't think from the beginning of the project life cycle, you are going to increase the cost, whether you take it to the public cloud, private cloud. But where are the servers located? What is the throughput? What is the latency you are getting while accessing those data is also something you are going to consider, isn't it? So that is what you need to remember. So consider the cost that are involved in particular architecture, and you work with the product managers or the project managers to define and understand what kind of budget they have for those particular systems, and ensure that the system architecture and the architectural decisions align with the budget. So that is what the disaster recovery, cost, accessibility, regulatory comes into picture. Now, when I say scalability, we have spoken enough in the application architecture as well as in the data architecture. So I will rest this and go to the next section now. Okay.